In this video, we're looking at ECAA 2020, Section 1, Question 39. So we're asked to find the y-coordinate of the points on the curve y equals x squared that are the closest to points 0, 9 over 2. So how should we start looking at this question? Well, let's just find an arbitrary point that we can use to find the closest point. So we've got our point here, 0, 9 over 2. Let's pick another point that's on the curve y equals x squared. Let's say it's up here. And if we set our x equal to x, our y is going to be x squared. So let's say this is the point we're going to look for, that we're going to make this the closest point. So to know it's the closest point, we're going to need to find the distance between our points. So that's going to be this distance here, which I'm going to call a. And can we find an expression for a in terms of x? Well, let's use Pythagoras. We can make this into a right-angled triangle and use these sides to find a. So what's our side here going to be? Well, if we look, it's going to be the change in our y-coordinates. So it's going to be x squared minus 9 over 2. And we can do the same for our x here at the bottom. This is going to be x take away 0 or just x. So now we can use these to work out what a is. So a squared is going to equal x squared plus our x squared minus 9 over 2 all squared. So our a is going to be the square root of this, and I've just expanded the brackets out there to be x to the power of 4 minus 9x squared plus 81 over 4. So now we have an expression for a. How do we know it's going to be the closest distance? So the shortest distance is what we're trying to find. Well, if we're trying to minimise it, we need to differentiate. That's how we're going to find our minimum points. So let's differentiate our expression for a. And because our square root here is an increasing function, minimising just what's in the square root is the same as minimising the whole thing. So I'm just going to take the square root out. So this is what we're differentiating here, x squared plus x to the power of 4 minus 9x squared plus 81 over 4. And I can just make these simpler. So it's x to the power of 4 minus 8x squared plus 81 over 4. So have a go at differentiating this and see what you can get. So our answer is going to be 4x to the power of 3 minus 16x. So we're just timesing the coefficient by our power, then decreasing the power by 1. So that's our final answer for our differentiation. So how do we find our x value for here? Well, we need to set it to 0. So here we go, set it to 0, and then we can just solve this like a regular polynomial. So I'm going to take 4x out, so it's 4x times x squared minus 4, and we can solve this by setting each term to 0. So x is going to equal 0, x squared equals 4, so our other x equals 2 and minus 2. So here are all our x values, but how do we know which one is going to give us the minimum? Well, to find the minimum one, we need to differentiate it again. So this is the expression we're differentiating. If we differentiate again, we're going to get 12x squared minus 16. And then we can plug our x's in and find which is the minimum. So let's start with x equals 0. If we substitute 0 in, we're going to get 0 take away 16 or minus 16. Is that the minimum or is that a maximum? Well, because it's negative, that is a maximum point. So it's not going to be 0. How about minus 2? So it's going to be 12 minus 2 squared. And we can see that here it would be the same if we just had our 2 minus 16. That's 48 minus 16 or 32. And because that's positive, we know it's a minimum. So both minus 2 and 2 are going to give us our minimum points. So now we have our x coordinates, we need to find our y coordinates. So how do we do that? Well, we're just going to substitute it into our graph expression. So that's y equals x squared. If we substitute either 2 or minus 2 in, it's going to be y equals minus 2 squared, and that's going to give us 4. So our y coordinate is going to be 4. So our final answer is D.